to all of you. So hope I'm audible and my screen is visible to everyone. Okay. So thank you all for joining the session. So myself, Deepthi, and I am a data scientist and also an IoT expert. I'm associated with 360 TMG and InnoDataTix since 4 years, and I'm a graduate from Electronics and Communication Engineering, and I have done my post-graduation in embedded systems. So I have 8 years of experience in teaching and also in consulting. So to begin with, so we 360 TMG bring a well-rich experience as we have gained a part of our consulting back to training, and 70% of our time goes in consulting. So we have many domain analytics being trained to all the participants. So as you can see on my screen, life science, healthcare, financial analytics, marketing analytics, and HR analytics, supply chain, cybersecurity, and for internal auditors and more. So hope you all are aware of the topic today, right? So it is the significance of regression coefficients with respect to P-value. So here's the agenda on my screen that will let us have a quick introduction of what is regression analysis, what is significance, what are the types of significance tests, and model evaluation, and understanding what is P-value actually is. So to understand this particular concept of data mining, right? What is data mining all about? So we are trying to do mining, right? Just like you do your coal mining with data. So in this, we have two things to be learned. One being supervised and other being unsupervised. So just bear with me if you already know this. If you are new to it, then it will be interesting for you people. So when you say supervised learning, here Y is known to you. When I say Y, when we have X and Y, X being the input and Y being the output. Here we know what is this parameter Y is in supervised. But here we don't know what is the output actually is. We try to just do some insights out of it based on patterns. We try to infer something based on the patterns. We don't know what is Y because all the inputs are considered. There is no specific Y term here. And now, when we come to this Y being known to us, output is known to us. So what you can do, we have two options here. It can be a number. It can be categorical, or I can say that it is non-numeric. Right? So today our topic goes with numeric data because this topic falls under numeric data, and when we come or deal with non-numeric, it is classification. The technique is called as classification. So when I say numeric, we are going with regression techniques. So what does this regression technique is? The regression technique is nothing but you are doing some predictions. You are doing some predictions. So you know what is prediction, right? You are predicting, like we babas always predict something, right? So for any dependency, you have y and x. So for every value of x, you are trying to predict some output y, right? And how well these are dependent, right, is what is our topic today. So when I say this, okay. So to begin with, when I say two values I have, out of this, you people know that y being the output, x being the input. So these are the relations associated with the data. So x is input, y is output. So we are trying to get the relation between these two. So what is that relation actually called as? Correlation. The relation is called as correlation. So this correlation is given by small r. This is nothing but given by small r. When I say, see the plot, if you see, it got scattered, right? So this plot gives us the inference of how is the relation. That means the direction, right, is r. For every change in x, is there any change in y? It means that the concept of linearity and how well the strength is there between these two. So by seeing these things, you can say that yes, it is in positive direction or negative direction, or there is no relation between both the variables, right? X may increase, y may decrease, x increases, y also increases. Anything may happen here, right? But there might be cases where there are no relation between both the variables. Let it be not only one variable x. Let us say if you have like 100 variables, are they important for us to do prediction with y? Let's understand that. How is the scatter? How is the strength? How is the direction? All these are represented by a single coefficient called as r. Right? This is nothing but your r. R is a correlation coefficient. So when you do this analysis, right? When you do R analysis, that is, which is nothing but the correlation coefficient, this value being 0.85. And this is one way to understand whether they are dependent or not dependent. Are is this important for y, for prediction of y or not? If there is 0.85 relation, it's very good. Strong relation means the strength is more. Right? Now let us come to this regression analysis. Something called like the coefficient of determination. So whenever you do any prediction between x and y, so there is something like linear regression. Why am I calling it as linear regression? For every change in x, you observe some change in y. So just like this, right? So when you have this, y can be anything, x can be anything, right? So if I say y is something like ice cream sales, right? Or x can be the temperature, anything like this. If you have only two variables, it's up to you how you want to plot the graph, right? So whenever you are trying to build a relation with this, Yeah, you are trying to form an equation. So what do? You write the equation like lm y tilde x. Right? Whenever you build any model, I am building a regression model, that also a linear model. This is how I build the model. So when I build y tilde x, I get the model is built. Now I try to analyze that particular output of that particular model. I need to analyze. So how do you say that the model you have built with all the variables is fine enough? You can proceed further. You can say your client, yes, this is a perfect model. That is determined by your R square. So R square will decide, right? R square. Remember, this is small r, this is capital R. This R square is nothing but coefficient of determination. It is nothing but the percentage of variation with output, that is y. So what do you call now y? Y is a dependent variable. X is independent variable. So whatever x's you have used, x1, x2, x3, are they important for y? So that will be understood by finding your R square. So this is explained by the input variables or the percentage of response variable variation. So you call this particular x as predictors. You call x as predictors, predictor variables. Right? So let us understand what is this. So higher the R square. See, it is nothing but you say that it is a moderate correlation. R square greater than 0.8. Very strong correlation. Right? So R square is nothing but your coefficient of determination. So we need to calculate this R square here. So to calculate this R square, you have few parameters on my screen here. Let us see what all those are. So to begin with, if you can see here, I have day, I have ice cream sales, and I have temperature. And you have, if you can see here, x being my temperature and y being my ice cream sales. So which is dependent and which is independent variable here? X being independent variable and y being dependent on x. So remember in our school days we have seen y is equal to f of x. So x is independent, is not required. Some value it can be, but y always has some influence with respect to x. Right? So when I try to find the relation between this temperature and ice cream sales, if you can see this line, right? This line is nothing but your predicted values line. Y hat. Line in statistics is called as y hat. It is a prediction of y for any given value of x. These are my x now. When x being 12, 14, 16, 22, and 20. Right? If you see, maybe at this particular point or here, somewhere, y hat is used to assess how many sales are there and that can be expected. Right? At 24, if you can see, right? You can expect this. You are able to predict. So you can do wonders, right? So same thing. At 14, the sales are very low. Why? Because when the temperature is 14, maybe no one is willing to have ice creams here. Right? So when you are doing this, you have plotted the graph here, you will get some equation. You get that equation is called as sample regression line. So whatever line I have got, I write it as y hat line, which is being, so what is this line called as? This is a line, right? Linear line. So how do you write? That is nothing but your mx plus c. C being constant and m being slopes here. So when I write y hat, which is being a sample regression line, is just, we are familiar with this number, so I'm writing it. If I do, just now I told you, right? You can do lm y tilde x. You get this, the output, the summary of this particular model, what you have built with this particular data is known to you. So I get some equation. This is my equation. So this being my constant and this being my slope for this variable x. What is x here? X being the temperature. This is the coefficient of x is 123.54. But how these numbers have come now? So the distance to the line itself is minimized and sum of all the distances to the line. Right? Sum of all the distances to this line, if you calculate, this is the main line, right? This is away from the line, near to the line, right? Hope you have a line like this also here. Upside and downside, you have both. So then you can say that these upside, you call them as positive terms. These below the line, you can call them as negative terms, right? So the distance to the line itself is minimized and sum of all the distances, all these distances to this particular line, right? That sum should be minimized, right? That sum should be minimized. So how do you write? That is nothing but sum of all those called as nothing but the error terms, right? That is nothing but sigma e. Sum of e should be equal to minimized, so 0. So you can draw infinite. We can get the line anyway. You can get a line. If I draw here something like this, you can get a line like this, any line, right? But the data with respect to line, the data with respect to the line you have drawn, right? But the sum of the error terms should be equal to 0. So because of this positivity and negativity terms here, we square these distances to remove that negativity. So what we do? We write sigma e square being equal to 0. So what is this now? Y hat? Y hat is perfectly defined as line that minimize the sum of the squared errors. So only one line can be drawn, right? Only one line can be drawn. But here, as I told you, we had this terminology, sum of, here we have the terminology SSR and SSE and SSC. This is nothing but sum of the squares of the regression, sum of the squares of the errors, sum of the total square. That's the reason we are writing square here, right? So let us see it. If you consider this blue color line being mu, this blue color line being mean, that is nothing but your mu, main line, the average drawn. So what I write that line as? Y bar. I write that line as Y bar. So regression is what we are considering here. The point here is why a particular variable varies. It means it's all about, we are only interested in why that particular variable varies. The question is all about this one. So if you take this particular data point, right, or if you take this, why it is beyond this average line, or if you take this particular data point, why it is below this average line, right? Around here, if you see it's 800, why it is not there with my line, with the average line, why it is? So we are separating the distance from this Y bar line into two parts. One will be explained deviation and other will be unexplained deviation. As I told you, this being your Y hat, right? And what is your, this X here, what I've drawn that mark here, that symbol, this is the predicted value. Predicted value, that's why I have written as Y. For some by X value here. So using the maximum temperature, we are estimating the sales maybe around at 23 degrees Celsius. We would have expected something more than the average, right? This is your average line. You have expected something more than the average, right? So what it is now, if you take from this line to your average line, this is the expected deviation from the mean, and you call it as explained deviation. This is nothing but explained deviation. From where? From your mean. So how do you write it now? You have, this is your predicted value minus y bar, right? Y bar. Now, what is this now? This is even higher than our expectations, right? This means this is an unexplained deviation, right? This is an unexplained deviation. This is higher. So you write this as yi minus, right? So in total deviation, what you have, this is nothing but your now unexplained deviation. This is your unexplained deviation. So explained deviation plus unexplained deviation from the mean is nothing but your total deviation. Is nothing but your total deviation, right? This is where you got our SSR.
Suddenly, Dipti, you there? Hi guys, I believe there is some issues going on from our host's end. So we're checking on it. Please bear with us for 2 more minutes. Apologies about that. We'll soon get back on the webinar. Please bear with us. Hi, Dipti. Can you hear me, Dipti?
Yes, yes.
All right. Guys, our facilitator is back online. We are sorry about this backdrop. Please bear with us with this. And thank you for your patience, guys.
Yeah, sorry, actually, it's raining heavily here, maybe because of the internet issue. I'm very sorry. Okay, I didn't check it. Okay, so where are we here? So we are trying to calculate R square, right? R square is nothing but you are calculating sum of the square with respect to regression and by total. So depending on your E, right? Depending upon your errors, your R square is decided. So when you have very less R square is increasing. It means that very, very good model. The model we have built is very good, and whatever we have find it out or whatever we have predicted is very good, right? So when we do this, we know now how to do improve this R square, right? So we have to reduce these errors. How to reduce these errors? We have to draw a line which will have the maximum data points falling on it, right? So how you can do that? If your line is like this, so what you have to do, you have to draw another line like this or another line. How you can make that? There you will do transformations, right? This is how you do transformations. So when you apply different transformations, your R square value will increase, right? So this is what is actual regression analysis is all about. So now let us understand the data set here, right? This is something related to the statistical analysis, right? On the factors which influence the life expectancy. So I have the country, I have the year, I have the status of the country. This is the life expectancy. This is my output column. As I told you, we will predict output here. What factors are influencing this particular life expectancy is what we are checking. Right? So we have 1, 2, 3, 4. I have only given here 4. Right? I have 22 variables which are helping us to predict this life expectancy. Right? So you know what is mortality rate, infant deaths, how it is related with alcohol. So I have used many variables. It's my wish I can have 25 variables also I consider because I have collected the data with me. But all these 25, are they useful for my prediction of Y is what? We need to understand. That is the inference, what we have to get. That is nothing but, are they significant enough or not? Right? This is what we have to do. So assume that I have built the model. Okay, let me show you otherwise. The data set first. Right? This is my data set. I have the country, year, status, alcohol, percentage, hepatitis, measles, BMI. So I have 22 variables here. But how come these variables, right? GDP, income, schooling, right? So 22 variables are there here. So for this 22 variables, I have collected the data and I have so many number of observations. Leave about that. So for different countries and different years. Now, when I try to build any linear model, right? So I want NumPy package. I want pandas to work with the data set to do normal calculations. I need NumPy package. For observing any type of plots, I want matplotlib package, right? So we need statsmodel.api to do ordinary least square error, that is OLS, regression technique. We need this. For advanced visualizations, we need Seaborn package. So to train and test the data, we need this. So let me load all these things. Let me show you the first 5 columns, the data. along with 5 observations. So I have to check whether whatever data I've collected, are there any null values available there? Right? Okay, they are there. So I even want to delete some duplicates from my data. So life dot duplicated. Life is my data set. I'm duplicating them. Now if I see all the sum of the duplicates, now it is 0. Right? So for my data set, I feel that population, GDP, hepatitis, expenditure, country, year and status are not required for me. So what I do? Normal drop. I didn't do any type of analysis on that. Simply I feel that these are no way important for my prediction of life expectancy. So what I do? I drew dropping all the columns. Right? Suppose if you have any observation missing, that also I want to drop, because that has a very good impact on your output. Like that is the model building, the accuracy of the model I can say. So if I start doing analysis of my data, I use describe and I get the information. What is the count? What is the mean? What is the standard deviation? Or what is the minimum value, maximum value? All these things are available. But I'm interested in building the model and finding the correlation matrix. If I do fair plot of this, it takes time because I have so many observations with 22 variables. See here, 29. Actually, I was having around 2,600 observations. Right, removing all those null values and duplicates, now I am left out with 2562. Right? It's running here. Let's wait. So you see the plot, what I have shown you, the correlation coefficient, small r. So what does it tell us? How well they are related. Every variable with the other variable, how are they related? Are they strongly related or not? Is there any relationship between the individual things? That also should be understood here. Like, now we have alcohol and measles. Is there any relationship between alcohol and measles? Or measles and life expectancy? All these need to be checked in a single plot, that is pair plot, which comes from Seaborn package. Oh, where is my plot? Let me check it. It's running. See here, this is a plot. Right? Whenever you see life expectancy with life expectancy, this is the plot. See the relation here. If you try to draw a line here, where my cursor is there, this is how the relation is there. Here, few data points, right? A straight line, linear relationship, right? Here, a linear relationship. So maybe the variables are correlated. So how do you check that? I do correlation matrix and I get the correlation matrix here with all the variables. 15 by 15 matrix. So you have positive and you have negative. Life expectancy to life expectancy is 1. Some relation is there, but for few it is, so what I told you, 0.85. Right? So maybe if you are having, see here 0.99, but this is for 5 death, right? With infant deaths. So infant death with respect to the people who had death under maybe for 5 years, below 5 years, the relation is very high. That's why you got it as 99 here. If you have 0.677, diphtheria with polio, right? So very negative relationship here. Diphtheria with HIV. So this matrix will not only give a single combination, but for in between the variables and also between the output variable and the input variable. So quickly, let me build the model and show you the output here and understand the significance here, where we have just split it. Right? And now I do. These are my columns now. Now, I'm building the model, taking all the input variables. So as I told you, what is the equation here? It should be lm y tilde x. So there in R we use lm y tilde x. Here we are using OLS, ordered least squares. This is y and input. I'm taking all the inputs and now I'm looking at the summary part. Right? See here, the R square is 0.822. Right? And this is the output what we are interested in. So these are the coefficients and these are the p-values for us, and this is a standard error. So if you see, there are few things which are significant or not significant. So let us go back to our presentation here. See, I have taken only few of the observations here. If you can see, this is your regression output what we got here, right? So how do you write the equation here? We write the equation saying that life expectancy, right, is equal to, this is your y. So you get beta naught plus beta 1 into mortality rate, right, plus beta 2 into infant deaths plus beta 3 into alcohol plus beta 4 into percentage expenditure and like that, beta 5 into all the values. Right? Now from these coefficients, right, this is beta 1, beta 2, this is your intercept. This is nothing but your beta naught, constant. So from here, if you start beta 1, beta 2, beta 3 and beta 4, right, we can never know what will be the true slope here. Right? So beta 1 is equal to 0, suppose. It means that there is no effect of this mortality rate on y. Right? There is no effect. So what is it? Beta 1 should be some non-zero value. It means that it will have some effect on the output. So we can never know the true slope here. So what you are calculating here? We calculate the sample 1. So by calculating this B1, we try to get the inferences for beta 1. So beta 1 is the main slope, or I can say population slope, but this becomes your sample slope. So this is the estimate of the true value of beta. You call it as an estimate here. Right? So this is making the inferences or reference to beta 1 here. Right? You can get a slope, as I told you, positive. You can get a slope negative. Right? It talks about the correlation. So it depends upon, you may get 0.8 as I showed you, 0.2, 0.6. It can be negative also. See here, you have seen negative. Right? Now what is this being significant? What is this coefficient being significant? So usually when you start with all these inputs, adult, infant death, alcohol, personal expenditure, schooling and all those things, right? You try to get an equation. Right? What I have written the equation. But if you start with null hypothesis, what will be your null hypothesis? It will be nothing but whatever beta is A, that is equal to 0. It means you are assuming that there is no relation with or relation between x and y. Right? So what will be your alternative? Beta not being equal to 0. Right? We infer that the variable is significant enough. So how many variables you have right now? You have 22 variables. Right? One being beta not, B0, which is being constant or intercept. This needs to be there for the equation to work, whatever equation I have written. So whatever y hat value I have now, beta 1 with all the variables, beta 2 plus beta 3 till I have beta 22. Right? If I substitute for any of the country here, if I take this one, Afghanistan, and write 263, 62 in place of x there, right? I get an equation. I get a value there. What does that value represent here? Right? Whatever brackets is there, I substitute the values in the brackets. So that value will be my predicted value. That value will be my predicted value. If you see here, this is positive, positive, positive. But if you see this percentage expenditure, it is very, very low, 0.004, very least. Maybe this is having very less effect on your output. What is that output? Life expectancy. Right? So what do you understand by minus 0.0168 added mortality? Right? So expected life expectancy can increase or decrease here. So it is decreasing, minus symbol. By how much? 0.0168. This many times it is decreasing. Now, whatever you have here is your predicted value, but some y value will be there, original value, right? That value is nothing but your error calculation here. That is actual value minus your predicted values, right? That is nothing but your standard error in the equation. Right? The average expected error term for this particular sample value. Right? So that is what is there. For every increase of average mortality, the life expectancy is decreasing because of the minus sign on an average, holding all other variables being constant. So you have the positive relation or negative relation. It depends. So you got for all the variables here. Right? Now let's talk about the t statistics here. The t value you are seeing here. Right? So it is adult mortality, infant deaths, alcohol. Right? So what is this t and p, and how you are getting this t value here? So t value is nothing but whatever coefficient you have got and whatever the error is there, right, deviated from the line, the standard error. Right? So what is happening here? You get here, so I have divided my 0.0108 with 0.029. So what is that I got here? 0.374, which is nothing but my t value. Right? It is nothing but my t value. So based on this t value, right, we will get the p value here. Right? How extreme the coefficient is. Right? If indeed the population coefficient is equal to 0. Remember population coefficient? We don't know this. We are only getting B1, sample 1. How extreme? That p value will help us to know. How extreme the coefficient is there if indeed this population coefficient is equal to 0. So initial hypothesis is each of the coefficients at the population level are 0. It means that we are assuming that there is no effect of variables on the output, right? H naught being equal to 0. What if we have here the sample, right? What actually the p-value is giving us? The p-value is giving us the probability of this coefficient occurring just due to random chance. This is only due to a random chance, right? So when you do this, right, just let me, yeah, this is what we got here, minus 0.374 and 0.374, plus and minus, positive and negative. So if you calculate the two areas here, right, you got the p-value 0.709. This is what you got here with the respective, the t-value with respect to the coefficient, right? So what does it mean here? When you got the p-value as 0.709, so how far it is away from a 0 so that we can reject null hypothesis, H naught. So p-value is what? What is the probability of getting a sample as extreme as that H naught is true or not? What is the chance here? 70.9. So what is the 70.9? It is very close to 0. Very near. This being 0 here. So it means that it is no way, there is no chance. It's very, because the sample value is very close to 0. No way we can reject this B2. Right? And that is the reason we are not interested in taking this particular variable. Right? So let us go with another calculation. Infant deaths. If you see here, the same way I am doing the coefficient by the error. So we are doing coefficient is 0.928 by this error, we got this t value. Right? See the p value 0.019. If you try to plot it, right, some values here, right, the two areas is giving you the p value here. So the null hypothesis is true. So the chance of we getting a sample as extreme as we did, right, is 1.9. So what is actually a threshold point here? The threshold point being 5% chance you can go wrong, right? So 1.9 is less than 5%. It means that this particular variable, infant underscore death, is significant enough. Is significant enough here. So we are interested to take this into consideration. This particular infant underscore death into consideration. Though you have negative impact or positive impact on your data with respect to coefficients, with respect to your y, right? This is how you decide. And see here, if you even get the output related to the confidence interval at 95%. So whenever you try to draw a bell-shaped curve here, right? This is your area being covered. 95% of the area is being covered. So the probability of the value falling here. Why? Because when you're predicting, you're not predicting a single value. Why? The probability of a single value is becoming 0. Right? But what we want actually here, we want an interval here. So that interval values are here. Right? How well the values are falling in this particular region. So you have 2.5% here, 2.5% here, totally 5%. There is a 5% chance of you going wrong. This is a threshold point decided. How much less the p-value should be there? What happens? when it will be accepted, when it will be rejected. If you see here, this is low, this is low, this is low, this is very high, it means it is greater. So we are not interested, and maybe this is not having any effect on your output, like expectancy. Right? How we can conclude now? So for every value of coefficients here, right, these are the values you got here. So you have measles, you have alcohol, right? You have thinness underscore ear, all these things. Will you delete them, or you check more detailedly about this? Whether are they important for us for the output of y or not? Are they important or not? This is what you need to check. There are various ways to check here, right? So what we can do is we can individually build a model, taking them into consideration, taking only that particular variable. That is nothing but you are testing the significance. So you have three types of tests here, considering with respect to the significance. Right? One is joint significance. Right? One being joint significance. That is nothing but the overall significance. It means what is the equation I have written just now? We have the equation of taking all the variables into consideration. Right? Taking all the variables into consideration till beta 2, 22. Right? So what will be your H naught for the first one, for joint? Right? All these are 0. Right? All these values, beta naughts, are 0. And HI will be, all these coefficients are not equal to 0. It is talking about all the coefficient. Relation is there, no relation is there. That is your joint. That is nothing but your overall significance of regression. Right? So now you can take two individual variables, beta 1 and beta 2. 2 you can consider. Right? So just suppose if you are trying to predict miles per gallon of a vehicle, you have weight of the vehicle, you have top speed of the vehicle, you have volume. So these three are there. So how these combinedly are affecting y, individually affecting y, grouply how are they affecting y? This is your joint, like combination of only two and single. Right? For each you have different hypotheses. For the second one, if you take, what will be this hypothesis here? The test will be your beta 1, beta 2 should be equal to 0. But what will be your alternative? At least one beta I should be not equal to 0. At least one should not be equal to 0. So here it is the same, bi. So I is changing now. I is changing as first variable, second variable, third variable till 22 variables. Right? For individual, if I write, you have H naught is equal to beta I, which is equal to 0, single. Right? Each variable's impact on y. Right? So how does it depend here? That depends on your p. P-value is being greater than 0.10. P-value being less than 0.1. Or you can write 10. Right? P-value being less than 0.05. Right? So how much less? It is 0.0001. So this being excellent, this being okay, fair enough, you can consider. Means that variable has fair enough relation with output variable. And this can be marginal. If it is greater than 0.10, it means that it is not significant. This being not significant. right? So that is what is done here. Let us do it. See here, I have whatever which I feel that they are not coming into, they're important or not, I do individually and try to find out the summary. See here, individually they give a different p-values, different coefficients, right? If I do individually, the third one what I'm doing, test. But if I do combinedly both, right, I can add, see here, thinness, two variables I am adding. I can check the significance in this way. Both combinedly are having effect. No, these two combined also they are not having any effect. They are significant enough, right? So only considering those two individually, on overall significance they are having effect, but individually they are significant enough, right? Maybe because of few values available here in the data, right? The values which are available in the data, maybe the few outliers are there. Maybe because of that reason, these are showing some impact and they are not being significant. So there are various plots available, right? Which observation is having impact? Is there that particular thing? You can drop it and you can do it, right? So even you have something called like variance inflation factor. So when you do variance inflation factor, right, that is nothing but you have the formula is 1 by 1 minus r square. R square being the coefficient of determination, right? That is nothing but you can do something like VIF. Why you are doing all these things? Because you feel that this value, whatever you got, right, there is no significant, the p-value is not up to the mark. It is selling that no, this particular variable is not having any impact on y. So there are the various ways you are doing. So if you calculate this is the formula for calculating variance inflation factor. This being greater than 10, less than 10, right? If it's greater than 10, it seems that maybe because of this overall significance is affecting due to the variables, means inbuilt relationship. Means same, these two are having same information. So one of them can be deleted. But collecting data is very, very costly offense. So what we have to do, we can't directly delete one column, right? We are able to find out what it is using this. So after you find out this, here, see here, I'm just trying to find out for thinness. Taking this as output for independent variable and taking all other input variables. I got this value VIF as how much? 8.8. Okay, it is 9.1. Right? So what I do? I can do for all the variables here. Right? So after you get which value which is greater than 10, those variables can be removed. Right? Like going for a second chance, because deleting all the variables is not a good option. Right? So I have removed few things here and check the summary here. Right? So this R square is 0.815. So this is more important for us. This will say that out of 100 data points, 81% of the data points are predicted correctly. 81.5% data is predicted correctly. How much has gone wrong? Rest of them. 100 minus 81.5. More than 19% of the data is gone wrong. Right? This is how you do. You delete one variable and you try to understand how the variable is having impact on the output. But about what is actually this p-value is what we need to understand. What is this p-value is all about, right? Suppose let us take an example. I am flipping a coin 2 times. So I have the first flip. What I do, I get 50% of the time I get heads. And I have a chance that I get tails also 50%. So when I do second flip, again the same chance is there to get 50% heads and 50% tails. Right? When I flip a coin. Now the question comes, what is the probability of getting 2 heads in a row? Right? My question is, what is the probability of getting 2 heads in a row? So first you are tossing a coin, heads and tails, suppose. So this probability is 0.5, this probability is 0.5. Now second time when you toss it, you have equal chance again. Here also you have the equal chance. Heads and tails, right? So what are the combinations here? This is 0.5, right? This is 0.5 chance. Half chance is there, half chance is there. So what are the combinations you get here? After the second flip, you will get head, you may get head tails, you may get tail heads, you may get tail. These are the various things. So what am I asking here? I want the probability for 2 heads. So number of times, how do you calculate probability? Number of times you have heads by total number of outcomes is what you calculate as probability. Right. So what you do here, I got 1 time as head, total is 1 by 4. So the probability being 0.25. Right. Now the same thing I ask you, 2 tails. What's the probability of getting 2 tails? So that also is the same because you get tails 2 times and total number of outcomes is nothing but 1 by 4, which is nothing but again 0.25. So you know that both the probabilities here are same. Right? Now if I suppose ask you, what is the probability of getting 1 head and 1 tail? What's the probability of getting 1 head and 1 tail? Right? You should take 1 head and 1 tail. Right? So it can be, what happens? It can be head first or tail first, or it can be tail and head first. These two have occurred. This or this? Both by total. So what is it now? This is occurred 2 times, no? The 4 combinations. Head, tails, head, tail, and these are 2 times occurred. So this 2 by, again 4 combinations. This is very easy. So you get 1 by 2, the probability being 0.5. So we are not bothered about the order here. Now we'll calculate p-value for the same thing. So what does that p-value actually do here is, p-value has 3 parts. So if you cut it, this is 1, this is 2, and this is 3. If you calculate the first part here, what's the first part here? The probability that the random chance generated the data, right? So the first part is the random chance generated. The probability for the random chance generated is head and head. Some random by 4. This is the first case. So the randomly generated, the first part will be 1 by 4, which is equal to 0.25. Now what I do? The second part here is something else that is equal. So something else which is equal to head and head is tails and tails, which is getting the same thing. So that is equal to 1 by 4, which is equal to 0.25. Any rare cases here? Right? Do you have any rarer cases here? You don't have any rare case here. So this third one will be equal to 0. So if you add up all these 3, right? What is the answer you got here? 0.5 will be your p-value, right? And probability value is 0.25. This p-value is being compared with your threshold. What's the threshold? 0.05. That is nothing but 5% of chance you going wrong. Right? This is how you calculate the p-value. Obviously, we all say that yes, p-value and probability are same, but this is how it is calculated. Not only for head and tails, you can calculate any value. This is how the p-value is generated. You can go for t table, z table, or f table, anything. This is how you have to understand what is p. It is a probability that a random chance generated the data. Randomly, some data is generated, and that data, whatever it is, equal. And some rare cases have been occurring. You are adding all the three parts and you are giving the p-value here. So finally, what all things we have learned here? So how the significance of coefficients is playing an important role in the selection of variables. Right? How the effect of inputs are there on the output variables. Right? By increasing R square, what you are increasing? You are decreasing your errors. Sorry, by decreasing the errors, you are increasing your R square. That way your model will improve. From, if it is 81%, it means that your model is very good, but not in a scenario of medical scenario, right? But probably the errors are very less to your model. So what you have to do to get a better R square, apply transformations to your input variables. You know what is transformations? You are applying different mathematical transformations. Log, you can do square, you can do exponential, you can do square root, whatever transformations to input variables so that this will be increased. And now you know how this is different from your normal probability. P-value is different from your normal probability. Now, so finally, we are accredited to City and Guilds, UTM, right? IBM, Panasonic, and CareerX. So what we actually is that we have launched a full stack data scientist program in collaboration with the universities, UTM, right? And this is UK based establishment done like, you know, we have like for 150 years history is there, which is backed by Queen of England here, and it is very much prestigious enough that people who don't do graduation in UK, they do City and Guilds certification, right? Accredited programs, and they become joy employable, right? So this is one of UTM is one of the top 5 universities of Malaysia, right? So, and finally, these are our social media platforms. You can connect us at these platforms here. So thank you all. Right? Any questions? Oh, so many answers. Thank you. P-value, if I think I have answered your question, right? Expected value and predicted value. Sheikh, are you there? Yeah, expected value is something, you know, you are doing a same experiment n number of times. That value will not change. Predicted value is what you are doing for a single observation. Hope I answered your question, Sheikh. Yeah. So hope I have given you much information with the significance. with respect to p-value and how is important for us to choose a variable. Shruti, these NumPy and Seaborn packages are the packages from Python, where NumPy is for normal calculations, right? Your math calculations, but Seaborn is a package for more visualizations, better visualization. You can add colors, you can do n number of variables at a time. So like a scatter, you have something like a scatter plot, right? The scatter plot is nothing but you get only two variables, right? But when you see Seaborn packages, all the variables with individual variable, you have the plot. Just now I have showed you. So any questions, anyone? Yeah, Python is a software which is good enough. It's free. You can install Anaconda Navigator, right? So you have so many other terminals available here, applications available here. So yeah, this will be posted and the link is given in the chat, right? You can just even refer to it after the session. So can I ask you for questions now? It's not a part of statistics, a part of statistics in regression analysis. It's a part of it is a part of regression analysis. So when you do regression, right? When you do a regression, it's a model, right? When you're trying to build a model, when whatever y you have, output you have, it's a numeric. When you build regression model, how will you say that the model is good or bad? This is how you have to say. You have to see the capital R² value. You have to see. We can say I want to predict whether the person is cancer patient or a non-cancer patient. I'll check BP. I take the BP variable, BP as one of my input columns, and try to predict cancer. Will it work? Right? How far this important, and this is more important with the significance of the variables is very, very important when you are trying to do regression analysis. Right? Hope I answered your question, Shruti. Not really. No certification for the session. Shruti, we are not statisticians here, right? Basic stats it's to be understood for us. For any business or any business scenario, we need to have the basic stats to be known. So all come. We are not statisticians. We don't get into statisticians. Only a few, like upper layer part. We need to understand. That's must. That whenever you are trying to build any model, right, for any business requirement, the first thing the client depends upon the client's request, right? He says that, okay, please, I don't want a better accurate model. Right? As I told you just now, we have the coefficient of determination, capital R square. Right? He says that let it be 65% accurate enough. Right? Then he gives you the input, all the input variables he says, and you feel that all these input variables are not giving good impact on Y. What do you say him? This is the model whatever I have built for you. But based on these statistics values only, you will say him, saying that this is what we have done. This model will only work for this, means we are not able to predict properly with the inputs what we have given. Shall I consider other inputs what are important to me? Shall I collect the data separately or will you provide us the data? Directly, no one is going to provide you with the data, right? Right, Shruti? Got the point? It's not compulsory that you build a regression model. You can build any model. You can, depending upon your type of the variables you have collected, the data being collected, it's up to you now. You can build any type of model. If Y is non-numeric, you can go for another model, classification model. If you are Y, when you have something like you want to do something like combine the people, you want to do clustering, you go for unsupervised technique. It's no restriction that you have to go for regression model. It is only when you can try up with different models and give a best accurate model. But the process of building the models is that you have to get the better accuracy and least error. The RMSE value, the standard error what you are getting. Oh, well, okay, Shruti. Thank you. Thank you so much. Okay, guys, then thanks once again, all of you, for joining the session. Thank you. Thank you once again.